Hello everybody, welcome back. Today what we're going to be looking at is 7.2 absolute value functions. In part 1 we're going to do some graphing. So an absolute value function can be defined as any function of the form y equals a absolute value b bracket x minus c closure brackets finish the absolute value sign plus d, where a, b, c, and d are real number values and a cannot obviously be 0, then the whole thing would be gone. It would just be equal to a straight line. So an example of an absolute value function would be your basic function. This is the base function, actually, it's called. It would be y equals absolute value of x. So I'll just graph that quickly with you. There's your absolute value. There's x, right? So if you take the absolute value of x, there you are. So that was x. If I take the absolute value of x, you'll notice that, see what's happening? All these y values, right? The x value is the same. The y value is becoming absolute value in all this. So basically, it won't go underneath the x-axis, okay? Unless there's transformations, of course, like we did in the quadratics. All right. So just something to keep in mind when we're doing absolute value. All right. So we'll look at it. We'll look at a bunch of functions. You'll get the hang of this. So we had x equal to -3, f of x is equal to 6. That means that f of x is still going to be 6, right? Because you're taking the absolute value of your y value, which is f of x. Same with this. This would be 4. All right. This would be 2. This would be 0. But the -2 becomes +2. The -4 becomes +4. The -6 becomes +6. And the 4 becomes 8. Okay? So this is just a general function. There's no value of this function. Okay? So let's look at these graphs here. So it says use this graph to sketch this graph. So I know what this function is, but they're just giving you the graph. You don't have an actual function. You're not plugging it in a calculator. But what it means is anywhere you see any negative y values, they have to come out and become x values. So this line here, going decreasing, what's underneath the x-axis is going to come up like this. And I'll draw this for you on the Desmouse. So it's actually -x, and you wouldn't know that, and that's fine. And then the absolute value of x. So you'll notice there's your x value. That's what you have on your page there. And once you add in the absolute value sign, okay, what happens is all of these values are gone, right? So I'll get rid of that. And there's your absolute value. So basically it's symmetrical, right? It's going to be symmetrical of the x-axis. So it flips up, if you wish. Okay? So we'll take a picture of that graph for you. So if we had any function, and this one is just y equals f of x, so this is a general function. We don't know what it is. Now I figured out what it was. It was -x. So if we take the absolute value of that, remember all of your negative y values become positives. Okay? So it's very important we be careful with that. All right? So you don't have anything underneath the y-axis, or sorry, the x-axis here. Now again, you could, it'll depend on the transformations, but if the whole function is taking the absolute value, that means none of your y values will be negative, and that's what we have here. Okay? So the next one, we have this function, it's called g of x, and we're going to take the absolute value. So what's going to happen is this part that's underneath the x-axis is going to flip up and come like this. It may kind of look like more of a quadratic, right? It's not, but you get my idea here, right? We're just doing a sketch. So I'll do my best with that. Again, I don't have the exact function, but what I did was I just made one as close as I could to that. So for you, sorry about that. You notice I have this graph. Looks something like what we have there, right? Continued on. And then if I take the absolute value of it, you'll see that coming in the blue. It takes this part and comes up and gets rid of that. So that's what your function looks like. Okay? Again, this isn't perfect. It's just a sketch, and we'll just sketch that out. Okay? Alright? And I just have the continuation there. But the point is, to get an understanding of this part of the curve, is starting to move up. Okay? Again, these aren't perfect, but again, we're just doing a sketch. So the idea is to understand that the negative y values become positive because you're now taking the absolute value of that function. The next one, same idea. This one we have a quadratic, and you can clearly see that the quadratic is opening down. This one's going to be kind of neat to see what happens. So I want you to think about it before I post the video. So I'll just take a second here and take a look at it and see what you think is going to happen. Okay? Try to get an idea of the sketch in your mind. So if you guessed the fact that this is going to actually take this part of the graph, so the negative, and flip it up, you'd be absolutely right. And it kind of comes out like this, kind of curves out. So let's see that in live action with the graph. So I did graph this one here, and it is the quadratic. And if I take the absolute value of that function, you'll see how it flips up, right? So that's what it's going to look like. It's pretty neat. Let's go back and take a look at what it did there, right? So we have the quadratic. Remember, this part is going to come up like this and flare out. So when we do that, there's the flip up, and then we just get rid of that, and there we are. Pretty neat. Okay, to see that, and it's gone, and that's what our new curve looks like. Pretty cool. So essentially, your x value stays the same, and your y value becomes positive if it's negative. Okay. So when I do my resketch, it just looks like this, right? We keep all of our positive y values, and our negative y values become positive. So basically, if you just look at this point here, we have at 3 and negative 6, it just becomes 3 and positive 6, and then we just sketch our line up, right? So it's not too bad. So those are just some looking at the graphs of any general function. So what we're going to do now is we're actually going to graph some of these functions. So I've already provided you with a graph here for this one. Okay, absolute value of x. So that means if x is negative 3 and you're taking the absolute value of x, that means it's going to be positive 3. Right? So that's the point, negative 3, positive 3 right here. Okay? And then 2, and then 1, and then 0, and 1, and then 2, and 2.5, and 3. Okay? And then you would just graph these values, right? Negative 3, positive 3, okay? And that's what we have here. And there's just your graph you would sketch. Okay? So what's the domain? The domain of the function is, well, look at the domain, the x value is going forever left and right. So we say that x, remember we can write this a couple different ways. I'll do the fancy brackets for you. Again, you can write it a different way. We have x such that x is an element of the reals, right? This element of the real numbers. Or we can do short for that without the fancy brackets, right? Braces, and we could just say that x is on the reals, or you can use your interval notation, which is fine, using infinity, and we have negative infinity to positive infinity. Okay, or you can just use infinity. It's fine. Right, so those are how to write your domain of the function. The range, in this particular case, it doesn't go any lower than 0, right? That's because we're taking the absolute value. Again, it's not always going to be the case. That's for a lot of these, obviously. So I'm going to steal that for a second for the range. I'm going to replace that with y. So y such that y is greater than or equal to 0, because it can be 0. And comma y is an element of the reals. Alright. Or we can just say y, right? We don't need the fancy notation. We can just say y is greater than or equal to 0, and that's cool. Or we can go from 0 to positive infinity, because it'll continue up forever. Okay? The 0 of the function, so the 0 is what the x-intercept is. So in this case, it is just the point. It's just the point 0, 0 in this case, right? Yeah, the y-intercept happens to be the same. Okay? And that's just a coincidence here. Alright? So I just had to answer some questions regarding that. Alright? This graph here. Okay? So let's look at the next one. We have a transformed absolute value function. So this one's a little different. We have y is equal to the absolute value of x plus 3. So I've graphed that for you. So you can just put that in your graphing calculator. Okay? I'll show you how to do that now. So when you're doing the absolute value function, you'll just hit y equals. And then you can go math, num, abs, the absolute value, and you get your symbol there. And then you can put in x plus 3, and we can graph that. Okay? So that's what the graph looks like there. Okay? So we look at our graph here, the domain. Alright? Domain is going to be, again, it's just x as an element of the reals. So it's going to be x is an element of the real numbers. Alright? X is an element of the real numbers. The range, again, in this particular, again, this is not always going to be the case. Alright, but the range to be y is greater than or equal to 0 again. Similar to the last question. Okay. And the zeros, your 0 is your x-intercept. You can clearly see in the table it's negative 3 and 0. Alright. So we want to add that in there for the 0 for the y-intercept, right? So it's going to be negative 3 comma 0. And of course the next we have is the y-intercept. And the y-intercept you'll see is at 0 and 3. Again, you can see it on the table. And your table of values can provide you with all this information as well. Okay, from your graph. And I'll show you that in a minute. That all can be obtained through there. Alright. So if we go into our graph, we can just hit second function table, as you guys are aware, and all those values are coming up there for you, right? Okay. Next, this graph's a little different, and the reason it's a little different is there's a part of the function outside the absolute value. So this is going to create something a little different that we haven't had happen yet. So if we take the absolute value of negative 3, we get 3, and then we subtract 2 from that, we get 1. Okay, so just be mindful of that. And then negative 2, absolute value of negative 2 would be 2, 2 subtract 2 is 0. And absolute value of negative 1 is 1, and 1 subtract 2 is negative 1. So this is the first time we see that we have a negative value. Okay, we haven't had that happen yet. And then we get 0, absolute value of 0, 0, gives us negative 2, then we go back to negative 1, and back to 0, and then 1, and then 2, right? Okay. So this time here, and that's because we're subtracting a value outside of the absolute value function. So it's creating and you may remember this is basically a vertical translation. Okay, so here, this plus 3, so many of you may have been thinking this from quadratics, that's a horizontal translation of left 3, right, the opposite side, and this is down 3. So let's answer the domain and range of all these questions, right? So the domain is still going to be x as an element of the reals. The range, this time, it can't go under negative 2. Alright, some people think of it as a vertex. It's not, but you can think of it like that, I guess. The 0 is at 2 and 0. And the y-intercept is the range, the value of the range value there, 0 and negative 2. Okay? There's your y-intercept. And then your zeros, we have 2 of them as well, right? It could be the plus, and also it could be the negative 2 and 0, right? Because it's on both sides this time. Okay? So just be careful there. That's all we have time for in this video. In the next video, we'll come back and we'll continue on with some of these absolute value functions and go from there. Okay? Thanks everybody for watching, and we'll talk again soon.